Right now, this pendulum swing plane is slowly beginning to turn, in Tokyo, about 8.8 degrees every hour. And yet no one is touching the pendulum. There is no sideways force twisting it. Nothing is turning it, so why does it turn? The answer comes at the end. Today, we make the whole secret of Foucault's pendulum visible. There is just one star of the show, a heavy bob on a very long wire. At the Pantheon in Paris, the wire is 67 meters long, taking 16 seconds for one slow swing. The pendulum's only job is to swing back and forth in a straight line. Here is the heart of it. Let's look straight down from above. A swinging pendulum feels no sideways force, so its swing plane stays fixed relative to the distant stars. The pendulum simply cannot turn itself. So why does it appear to turn? Let's pull back. What was turning was not the pendulum. It was the floor you stand on, the earth, turning underneath. The plane stays fixed to the stars, only the ground rotates beneath it. That is why it seems to turn. How fast it turns depends on latitude. At the North Pole the Earth spins fully underneath, so 1 turn per day. At the equator the floor does not rotate relative to the plane, so it never turns at all. In between, at Tokyo or Paris, it is partial. The rate is proportional to the sign of the latitude. Here is the map of the time for 1 full turn. Fast near the poles, growing to infinity toward the equator. At Paris, about 32 hours per turn, exactly matching what Foucault measured in 1851. Time for the answer. There was nothing turning the pendulum at all. It only swung honestly in a straight line. Its apparent turning is the unshakable proof that the Earth rotates. This was the first time humanity saw the Earth's rotation inside a laboratory. Nova Solver. Physics made visible.